In this video we're going to look at variables. Now variables are used to store data inside your program while it's running, and as such they're probably the most important thing, because if you write a program that doesn't store any data, it's unlikely to be able to do anything useful. The basic idea behind variables is a bit like algebra. It's assigning a value to a letter, or more likely a word. Different programming languages approach them in slightly different ways. So some programming languages require you to declare, so give a name and a type to a variable before you use it, and others have different types, so different types of numbers, whole numbers, floating point, large numbers, etc. But one of the reasons, again, I chose basic is that it's a nice gentle introduction to the world of variables and type, in that there are only two. And I'll explain what type is in a minute, but the first thing you need to do is you need to give your variable a name. So a valid name for a variable, well, you could use a letter like algebra, x, y, etc. And if you wanted to store the coordinates of a point on the screen, x and y would be perfectly acceptable variable names. But if you wanted to store something a bit more sophisticated, or you wanted to be clear what the variable was storing, it's a good idea to give it a name that reflects what it's used to store. So for example, if you wanted to store somebody's age, then you could call your variable age. That's a perfectly valid variable name. So valid variable names in just basic have to begin with a letter, so they can be a single letter, can be upper or lowercase. They can contain letters and numbers only in just basic, but other than that there aren't any restrictions, apart from you're not allowed to use a command or keyword. So you're not allowed to call a variable print or input, for example. Now I mentioned type a minute ago, so if I just call my variable age, that means it's a number. So if I just call my variable a letter or a word with nothing on the end, then it's going to store a number. If I want it to store anything other than a number, which we call a string in BASIC, so strings can include text, letters, but they can include numbers and also symbols, punctuation, spaces, etc., then we need to put a dollar symbol on the end of the variable name. So the same restrictions apply. It has to begin with a letter, can contain letters and numbers, but we put a dollar sign on the end to indicate that it stores text. So that's giving it a name, something that allows us to remember what it's going to be, and then we need to give it a value. So assigning a value to a variable is quite straightforward. We just type an equal sign, and then we type what we want the variable to store. So if I was 30, for example, I would type age equals 30, and that would just set the value of the variable called age to be 30. So you could think of variables as being a bit like boxes that you can put stuff in, or drawers or cards on a card index. If I'm storing text or anything other than a number, so the numbers can be negative or decimals, I've just used a positive whole number as an example. If I'm using text, then I need to enclose it in speech marks. So age 30, name Andrew. If I run my program now, what we'll see is it runs, but it doesn't do anything. So I've set the variables to contain those values, but I haven't done anything with those values. There's no error or anything though, so that's a good sign. If you try and assign a variable a value of the wrong type, so if I say age equals hello, for example, so remember that age hasn't got a dollar symbol on the end, so that means it should store a number. When I run that program, it hasn't run. It's highlighted the line that's given me an error, and in the status bar at the bottom it says basic compile halted type mismatch. Now what that means is there's a mismatch between the type of the variable has no dollar symbol, it's a number, but actually I've tried to give it some text. So that's one thing to look out for. So I can set the value of a variable, and I can change its value at any point throughout the program. So if this person suddenly ages while the program is running, I can update their age to 31, and because programs start at the top and run downwards, the value that the variable has is the latest one you've given it. So if I print age at this point, age will be 31, because although it was 30 to start with, I've now changed it. So it only prints the current value. So we can use our variables as though they were numbers or text. So I can print them. So I can say print age, and I can say print name $. And if I do that, if I run that program, what it'll do is it'll print 31 and it'll print Andrew. Okay, so if you've watched the first video on output, we can use all of the same things that we did there. So we could say things like name equals Bob, and then we can say print hello, and then we can use the plus symbol, or we can use the semicolon. So we can say semicolon name $, and what that'll do is that'll print hello Bob, hopefully. There we go, because it's printed the word hello, which is fixed, and it prints the name Bob. We're starting to see now that that technique is more useful, because we don't know when we reach that line, or when we create that line, what the name is going to be, particularly if we combine this with the input technique from video 2. So if we say something like this, what is your name? Then we're asking the person their name, we're storing it in the variable called name, and then we're printing it together with the word hello. Okay, so what is my name? My name is Ken, and it says hello Ken. We can also do calculations with number variables. So if I get rid of that, so this really is like algebra back at school. So if you say A equals 1, B equals 2, then we can either print A plus B, and if we do that, obviously we're expecting the answer 3, or we can create a third variable, and we could say C equals A plus B. So we're setting a third variable to be the total, and now if we want to display that total, we can just print C. So if we run this program, the output will be the same as the previous version where we printed A plus B, but the difference is that the result will be stored. So this is a bit of a waste of a variable, a waste of memory, if we don't want to keep the answer. But if we do want to keep the answer, then having a separate variable for that is fine. Now, I mentioned type, and we've got two types. We've got numbers and we've got strings for anything other than a number. But why does that matter? Well, let's have a look. So we just did this as an example. So print A plus B, and A is 1 and B is 2, and that gave us the answer 3, which was what we expected. But if we'd used a string variable instead of a number variable, what would have happened? So if we make A and B string variables, and then still set them to 1 and 2, but add them together, or in fact, as we said in the first video, the plus symbol concatenates, joins together strings or words. So if we run this now, what we get is not 3, but 12, because instead of adding the numbers, it's joined them together, it's concatenated them to give the number 12. So that's just a quick example of where things can go wrong if you have the wrong type for your variables. That sort of thing can also happen in languages that don't have types. So in JavaScript, for example, which is used on web pages, you don't have a type for your variables. So if you have A is 1 and B is 2, sometimes you get unpredictable results. Sometimes you get 3, and sometimes you get 12 when you add them together in that way. So you need to be a little bit careful. One thing that confuses people when they first start looking at variables as well is that if we have something like this, we have A equals 1, B equals 2, and if we have something like this, A equals A plus 1, what does that do? Well, it turns out that unlike with algebra, you can, when defining the value of a variable, refer to that variable itself. So if you say a equals a plus 1, what that means is take the new value of a, which is on the left-hand side of the equal sign, becomes the old value of a plus 1. So effectively, we're adding the value 1 there. So in fact, I don't need the b. I'll get rid of that for this part. So if a is 1 and a equals a plus 1, then if I print a, the answer we should get is 2, because we're effectively adding 1. Some programming languages allow you to add 1 just by putting sort of 2 pluses. So a++, for example, would work in JavaScript or C. So we can do that. We can also do that with strings. So we can say name dollar equals Tom, and we can say name dollar equals well, it would no longer be the name, would it? But we can say hello plus name dollar, and what would happen then is that when we printed that, what it would say is hello Tom, because it's originally stored Tom and then it's added hello to that. Both with this and with the number variable, it doesn't matter which way round you add. So if I'd have said name dollar plus some text, or if I'd have said a equals 1 plus a, that would have worked as well. It doesn't matter which way round, you can refer to them in any order. Okay, so just a quick recap then of the key points in variables. So variables store data within a program, makes them very useful. You can have as many as you want, but it's best not to have extra ones that you don't need, because that just wastes processing time possibly, and certainly memory. We've got 2 types in Just Basic. Ones with no dollar on the end, and they store numbers, but that can be a negative number or a decimal number, and variables with a dollar on the end of the name store text, and text can be words, but it can also be symbols or any other non-numerical information. We can use the equal sign to set the value. We can set the value several times throughout the program, and the variable stores the last value we give it, and we can print them out and use them in any other calculations.